All right, so we're starting a new one. We're talking about volume of pyramids and cones. So let's look up here. Let's see if we can identify some similarities or anything else we got with this. All right, so let's look at these various things. As you can see, there are cones, right? There's cones that are inside of a prism. You guys all see the clear things, prisms, like glass around it. Well, let's see if we notice any patterns here. If I wanted to find the volume of this prism, yes. What do you do? This is what part of your quiz was. Remember, it's big B times height. The nice thing is for true prisms like this, rectangular prisms, all you do is just multiply all the numbers together. Watch what happens. So I do 1 times 1 times 1. What's 1 times 1 times 1? 1. Good job. Nice job. So this has an area of 1. All right? That one has an area of 1. Its volume of the pyramid, though, so the prism is going to 1, but the pyramid is 1/3. Okay. Well, let's do this purple one down here. Multiply all the sides together. 1 times 1 times 3. What's 1 times 1 times 3? It is 3. Thank you. So that has a volume of 3, and its pyramid volume, the purple thing in there, is 1. Let's try over here with the red one, the tall guy. Same exact thing. 2 times 2 times 3. 2 times 2 is 4. What's 4 times 3? 12. So I have a volume of 12 for the prism. The pyramid is 4. Okay, got 2 more here. Little squatty guy over here, the yellow. 1 times 2 times 3. 2 times 3 is 6. 6 times 1 is 6. So I have a volume of 6 for the prism. The pyramid is 2. And let's do the last one, this guy in green here. Multiply together. 1 times 3 times 6. Well, 3 times 6 is 18. Times 1 is 18. The prism is a volume of 18, and the volume of the pyramid is 6. What do you notice about the volume of a pyramid relative to the prism? You guys notice any patterns here? How much bigger is the prism than the pyramid? 3 times. So basically the pyramid is 1/3 of whatever the prism is. And that's how we're going to derive our information. So let's go through here and try this. You can take any prism, for instance right here, whatever its base is, you can make a pyramid with that base. And you can make 3 identical pyramids. Don't believe me. When I heard this back in the day with my teacher told me this, here's what I was really saying. Let's use this green one for instance. I'm telling you that 3 total pyramids will fit inside that box. So in this little space, a clear space over here and over here, that means I can fit 2 more of those big green ones. Do you think does that look like that can happen? I can fit this green monster, 2 more of them in that area. Doesn't look, to me it doesn't. Maybe you guys, back in the day, young Coach Carr couldn't figure that out. So here's a nice little thing. I have this little demonstration for you. This is a square prism. I know you can't see this microphone, but I'm holding a square prism. All right? Right? Square prism, rectangular prism, how do you want to think about it? Its base is a square. Watch what happens if I take out one pyramid out of this. So I fold it, take it out. That pyramid is exactly the same height as the original box, right? So it's hard for me to demonstrate, but it's the exact height. I took out one of them. Watch what happens when I take out another one.
What's the listed pyramid?
There's lots of names on it, yes. Yes, it does say it. And Emily Nicholas, a lot of people. Basically, and then here we go. There's 3 identical pyramids. They are square pyramids, and they fit inside that square prism. So it is 1/3. Now this little thing here is basically if you got 100% on your test, you have to sign this. This has been around since the 80s. There's some 80 signatures in here too. Big little box. But that derives us what our formula is. So we take what a prism is. What's the formula for a prism? You guys just used it on your test. What is the formula for a prism? More importantly, you're right, space times height. Let's say big B times height. But if we want to find a pyramid, how many pyramids fit inside one of those boxes? 3. So I'm going to do 1/3 big B times H. And that's the formula. Extra one. So it's 1/3 big B times H. So it's exactly what you guys did before. We're now dividing by 3 as our final answer. So let's start setting these up. Well, just like you should have done on the test, you should write down the formula. First, identify the shape. What kind of shape is this? It is a, what do we say it is? Pyramid. So, volume equals 1/3 big B times H. There's the formula, so the first thing you should do is always write down the formula. The next thing is write down the pieces. Well, I know what 1/3 is, that's 1/3. But I need to find a big B, and I need to find the height. I just need two things, and I'm good. Very similar to what we did with the prism. All right, well, let's look at the big B. What sort of base is this? Pyramids are easy to identify because typically they're sitting on their bases, but also it's the thing that's not a triangle usually. So what kind of base is this? It is a rectangle, yeah. It's a square, but it's also a rectangle, I agree. How do you find area of a rectangle? It's going to be little b times h. The nice thing is I can figure out what this is. We're just looking, the big B refers to the base, so we're looking at this two-dimensional shape. Well, of that base, what is the base? Weird to say, but what's the B in that base down there? How long is one of those sides? 14. Well, how tall is that base? 14. Remember, we're just looking at the two-dimensional figure. So we can really easily figure out what the big B is. What's 14 times 14? 196. 196. So we now know the big B. Great. So we got one of the variables. Now we have to figure out what that height is. What is the height? 25. Is it 25? The way I'm asking, it sounds like 25 is not the right answer. But it could be because they throw you off sometimes. Ooh, it is a tricky one. Well, I'll tell you this. It is not 25. Everyone wants to say 25. But that is not the true height. That is like what we call the slant height. You'll learn more about slant height down the road. But that is what we're talking. You think about a ladder leaning on a building. That's how long that is. That's 25. I want to know how tall it is. So this takes us back to our idea of altitude. Remember we had that thing where altitude in constructions goes from the tippy top straight down, like you're flying the airplane. The pilot says your altitude is whatever, 32,000 feet. You take a string, drop it straight down, makes a right angle in there. Jason, question?
I know sort of an old question, sort of about an older problem, but you know, like the slanted cylinder we did.
Yes, the oblique cylinder.
How come that whole rule of slanting that makes it longer than it is did not apply there?
Because we didn't have to worry about, we weren't finding it. We don't have two surfaces anymore. You have to worry about that. But it's just the principle. It's Cavalier's principle. Just how it's a rule and that it maintains the volume. If you slant it, the volume stays the same.
But how would the height stay the same as like the height of the slant?
I'll show you a trick sometime with that and show you how it is. Ninth period, I'll show you. It's pretty cool. I'll show you with coins. All right. So when we're doing this, we need to find its true height. True height goes from the tippy top straight down the middle of the base. So that's you can really easily tell what it is. It goes from the tippy top. There's always down to the center. Well, we need to figure out how tall that is. Well, look what we just created if you piece this together. I made that line coming from the top to the middle. If I go over, what did I just make? What did I just make? A wedge, what'd you say? A radius. I did make a radius. Very good. Well, yeah, kind of a radius of a circle. I made a right triangle. So you do this a lot with pyramids. So what we like to do is try to draw this out to the sides, get a little better look at it, and see what we can do. We want to figure out what that height is. We don't know. That's the true height. But kind of what Galen said back there, if this goes down in the middle, how long is that piece? Half. So we take half of it. Half of 14 is 7. We know that's 7. And we also know that this side is 25. That slant height, kind of that ladder leaning on the side, this is 25. Somebody already said it. We create a right triangle because anytime you have a line coming straight down in the middle, it always forms a right angle. So is there a way to find this height? How can we find this unknown in this triangle? Yeah, blast from the past. You guys feel like it's, yeah, you know that because we do it every single time? Yes. Only one thing has to be true. What has to be true about that C value? It has to be opposite the diagonal. Yeah, I guess diagonal works out. Yeah, has to be opposite that 90 degrees. So there's my C value. Well, let's put it in that formula. A squared plus B squared is C squared. We'll say X squared plus 7 squared is equal to 25 squared. Let's do some simplifying if we could. So X squared is this. 7 squared is, what's 7 times 7? 49 is equal to, what's 25 squared? 6, 2, 5. Two-stepper, that's all it is. Two-step equation. We do so, what is that? I need to subtract, I heard someone say it out of the peanut gallery. Subtract by that 49 minus 49. So X squared is equal to, what's 625 minus 49? 576. Make sure you guys are following along, going through with this. And there's one last step. How do I get that X squared by itself? Square root. The root's on fire. There it is. So X equals 24. Uh-oh. What if I told you I knew it was 24 without doing the work? P-trip. It's a 7, 24, 25. I knew it before. I saw 7, I saw 25, saw right angle, boom, 24. So guess what? We now have the height. It's 24. Some of you saying, man, that was a lot of work. Well, we still have one more thing to do. We're not done yet. We need to figure out the volume of this pyramid. So I'm using that blue formula now. So I know my V equals 1/3. That's not going to change. What was my base area? What was my big B? What do we find that to be? It's on the board. What do we find the big B to be? Thank you. 196. How tall was the true height? How tall is this pyramid? 24. And guess what? We can now take this and plug it into our calculator. You can do 1/3. You can get 8 times 1. I don't care how you do it. But do in your calculator 1/3 times 196 times 24, and you will get an answer. This answer will have some numbers in it, and those numbers are 1, 5, 8, 6. I knew this number. 6, 8. And then we gotta look at our units, centimeters. What are we? Our units always in cube. That's it. There's the volume. I just really found the volume of the prism and divided by 3. That's it. And be ready, guys, because you're going to do the Pythagorean theorem a lot in this unit. Because a lot of times they don't give you the height. So you got to use it in different instances. So make sure you're aware of that and you can do that skill. Well, let's try number B. That's a number B. I got a problem with that. First thing first, write down the formula as you should for every one of this unit. I like to go through before the test and just put down the formulas. Then I'll go back and answer the questions. So, what sort of shape is this? Oh gosh. I'll give you a hint. It's a triangular. One of those things out in Egypt. It's the name of the note.
Triangular
Pyramid. Very good. So I'm going to write down the formula. The volume equals 1/3 big B times height. That's it. And just like before, we need those 2 bits of information. I need that big B, and I need that height. That's all I need. 2 bits. All right. Well, let's find the big B first. Again, you can find height first. I'm just going left to right. Doesn't matter how you do this. So big B, what sort of base is this? It is a triangle. That's why it's named a triangular pyramid. It's named by its base. So we're just looking at this one right here. That's what I want to figure out. Well, how do you find area of a triangle? Area of a triangle is? Yeah, 1/2 little b times h. Well, it helps a lot of times to draw these out. So right over here, I'm going to draw this base so you can see it a little clearer. We're saying that this is 6, and since it doesn't say anything other numbers, we're assuming that that's an equilateral triangle. So all those sides are 6. Well, let's try to figure out what we can. I know 1/2. What is one of the bases of that base? 6, you're right. So one of them 6. Just pick one as 6. Now we got to find what the height is. Okay, that's the tippy top. So I don't want that slanted height. I would say, all right, how tall is it from here to there? We know there's a right angle in there. How tall is that? I don't know. Well, I do know that this is an equilateral triangle. I drew a line coming from the top down to the bottom. It cuts it in half. So if the whole thing was 6, what's half of it? 3. So I know that this little side is 3. This one's 3 as well. That cuts in half. How does that help me find that other height? Well, what kind of triangle was this? What do we know about all the angles in equilateral triangles? They're all equal, and they're all 60. Very good. So I'm kind of writing in microscopic here, but that's 60 degrees. Well, I cut that in half. That means this is 30 up here. So we just made a 30, 60, 90 triangle. You could have done Pythagorean theorem. You could have said 3 squared plus x squared equals 6 squared to find one of those that missing height. But we don't need to, because we know it's a 30, 60, 90 triangle. How do I go from a short leg to the long leg? Small to big, I multiply. What do you multiply by 30, 60, 90? Radical 3. So I'm going to multiply radical 3. So 3 times radical 3 is 3 radical 3. So this is 3 radical 3. So I now have the height. There's a radical included in there. So my height is 3 radical 3. I can solve this. You can type in your calculator, everything but the radical, or we use our mental math abilities to go through. What is half of 6? Oh gosh, we're going downhill. Half of 6 is this number, 3. 3 times 3 is 9. So the big B is equal to 9 radical 3. You could put that in your calculator and get a decimal. Doesn't help you out because we want to find exact answers down the road. So there's our big B, 9 radical 3. What is the height of this pyramid? 9. You see how that line's going straight down the middle? That is its height. So this, in fact, is 9. Well, now we can find out the volume of it. We got our big B, we got our height, we got everything we need. So I know my volume equals 1/3. What did you say the base area was? 9 radical 3 right there. Just plug it in. So 9 radical 3. And I know my height. How tall is this guy? 9. When you have radicals in your answer, you'll see the top of the paper, it says leave in simplest radical form, or we'll specifically tell you how to leave it. We might say round to the nearest 10th, round to the nearest 100, or leave radical form. So we're going to do both ways here. We're going to leave in simplest form the exact answer, or simplest radical form, and then we'll put the estimated answer, because that radical will create a decimal. So let's use our mental math skills to go through this. What is 1/3 of 9? What's 9 divided by 3? 3. What is 3 times 9? 27, right? So don't do anything on the radical 3, just tag it on the back. So I know I have a 27 radical 3, and I include my units, and they're millimeters. What? Done. That is the exact answer. Exact answer. That is it. Well, what if I wanted the estimated answer, the approximate answer? Well, guess what I do with this in my calculator? Yeah, thanks. You just plug it in. Some of you guys are used to just plugging answers and guessing what you got. So when I do 27 times radical 3, what do I get? What do you say?
About
46.1. 46.8. Yeah, it's still millimeters squared. So just depending on how your question's asked, what it's asking for, make sure. Question. because I wrote a square instead of a cube. That's why I did it. I made a mistake. Sorry, microphone. Questions on that? Skip that pentagonal pyramid. You guys don't know about the opossum yet. We're going to ruin the surprise for you.
Let's get that one.
Or you ever know about the opossum.
Go ahead and flip it over to the back. Talk about a volume of a cone. Similar to how we said there's 3 pyramids in a prism, there are 3 cones, identical cones, in a cylinder. So the formula kind of says the same. It's just going to be 1/3 the volume of a cylinder, which is pi r squared times the height. Essentially, you're just finding the volume using the cylinder formula and then dividing by 3. Okay. Well, if we look at A, again, we know it's a cone, so we're going to write down the volume of a cone. 1/3 pi r squared times the height. And then we have to find the pieces we need. We need the radius, and we need the height. Okay. Can we identify one of those? Yeah, the height's 15. Height is right here. The part that's going up and down, there's our height. Here's the thing, do we know our radius? Looking at that diagram? No, we can't get our radius. But, what kind of shape do we have here? This blue shape. Yeah, right triangle. And we know this part of the right triangle is 15, and we know this part of our right triangle is 17. How can we find that bottom part of our right triangle, or radius? Pythagorean theorem. So we can do a squared plus b squared equals c squared. Okay, so label the side across from your 90 is always your c. This side's your a, and that side is your b. So a squared plus b squared equals c squared. What is 15 squared? 5. R squared. What's 17 squared? 289. Move the 225 over. And what is 289 minus 225? Square root both sides. So our radius equals what? 8. So again, you just use the Pythagorean theorem. We've done it a million times. Once you learn how to do it, if you're missing a piece, generally try to use the Pythagorean theorem. And then solve for your missing part. And we solved here, we got that our radius was 8. So now that we know our pieces, go ahead and put them in. So we're going to do volume is 1/3 pi times 8 squared times our height. And we want to leave this in terms of pi, so all you have to plug into your calculator is 1/3 times 8 squared times 15. And what do we get when we do 1/3 times 8 squared times 15? Again, 320. Tack on pi, and how would we label it? And this is scratch out that C. How would we label it? Q. We don't have all. So identify what formula you're using. We have a cone. Find the pieces you need. If a piece is missing, you might have to use the Pythagorean theorem. You might have to do 30, 60, 90. Right, central right triangle, something along those lines to get the missing piece. Plug it in, plug in your calculator, back on. Okay. Questions over that one? Okay. If we take a look at B, it says a sawmill, or at a sawmill, the circumference of the base of a cone-shaped pile of sawdust is 50 feet. The cone rises at an angle of 40 degrees to the nearest tenth of a foot. How tall is the pile of sawdust? Okay. Well, we're not really going to use a volume formula because we're trying to find one of the pieces. So whenever you're missing one of the pieces, you're generally going to make a right triangle. So here's our right triangle right here. And then try to use the Pythagorean theorem. I got it. Okay? Well, we can't really use the Pythagorean theorem because we don't have any of the sides. All we have is that one angle. Okay? And that angle's 40 degrees, so we can't really use 30, 60, 90. Okay? So what we want to do is try to find at least one of those pieces. And I'm going to use what they said at the beginning of the problem. The circumference of the base of a cone-shaped pile of sawdust is 50 feet. Okay. We can use that information to help us find the radius. Because what is the formula for a circumference? 2 pi r. So circumference is equal to 2 pi r. And we know the circumference is 50, so we can plug 50 in for c. And solve for r. To get r by itself, we want to get r all alone on that side. What do we have to do with 2 pi? Divide it. Good. Divide both sides by 2 pi. Cross this out. Left with r is equal to, make sure when you plug this in your calculator, you put parentheses around it. And you just do 50 divided by parentheses 2 pi, close parentheses.
No problem. Yep.
Plug that in. What do we end up in? Practicing, plugging this
Try to just go in your calculator so you know
Don't
what's
plug
going
it in
on.
correctly, you're going to get the wrong answer. What did you get? Make sure to include the pi because it's real world. Or you want decimals. What did you get? Did you put parentheses? 7 point, about 7.9, I think it's 6. About 6.95. Yeah, we rounded up 6. 6. Okay. So that's 7.96 or 8. Just for accuracy purposes, you got it. We're going to leave it as a decimal with a couple more decimal points. Usually we round to the nearest 10, but then that will bump it up to an 8. And just for accuracy, we can leave it like this. So there's our radius, 7.96. Okay? But we're trying to find the height, the part that goes up and down inside your cone. Well, there's no way to find the slant height to do Pythagorean theorem. And we already ruled out 30, 60, 90 because we don't have a 30-degree angle or a 60-degree angle. So we have to, again, think back to that right triangle unit we learned this first semester. We have to use SOHCAHTOA on this problem. Remember, when you use SOHCAHTOA, you start at your angle, and you go across, you label that as your opposite. Go across from your 90, that's your hypotenuse. And the guy left over is our adjacent. Which one are we going to use? Sine, cosine, or tangent based off what we labeled? Good, tangent. We have our opposite, we have our adjacent, so we're going to use our tangent. So you say tangent of that angle, 40, is equal to opposite over the adjacent. Mr. Carr gave you a nice little saying at the, when we did this unit, when x is up high, what do? Multiply. We're going to multiply both sides by 7.96. So in your calculator, all you have to do to figure out what the height is, you're going to do 7.96 times the tangent of 40. If you have one of our calculators, you go backwards, you go 40 times 7.96. And what do we end up getting as our height? X is about 6.7, so that means C is our height. So a lot of that right triangle stuff we did at the beginning of the year in first semester is coming back in this Pythagorean theorem, special right triangles, and trig will make an appearance this unit. Okay? Questions over that?